Hello guys, so what I'm doing for us today is to take us through what the wellhead section of my integrated facility looks like, the things I have considered, things I have put in place, and all of that. It is important for me to say this that uh, all of this that I've been doing, I've actually been factoring some of them to the various standards talking about the API. Uh, And of course, it is important to also stress that when you are doing this, you need to consider your transient condition of all of this. If you want to model a well-led system, it is important that you consider your flow assurance. And when I mean your flow assurance, I'm actually talking about what goes through your pipe flow, so which is from the wellhead all the way to the gathering station. I am not a subsurface expert, but of course, there are certain information that you need as a process guy, whether you're an operations personnel or process person. In order for you to model whatever you want to do, you just need that information from the team. And these are some of the things we all do together. So let me start from here. This is pipe seam, and this is what the team use in modeling their subsurface activities in terms of distance all the way from the wellbore all the way through to the well edge. And if you look at this place, this is where you have your THP pressure here. If you look at my cursor, so this is it. This is what they have. So when you remember when I say the wellhead pressure, I'm talking about the THP. So this is, we take it from here as a process person. We take it from here all the way to the station. When I mean the station, I'm talking about the gathering station. So back to my own panel, my own flow sheet where I start my own work from. I said I picked data from the team, the subsurface team. So in order for me to do all of that, to condition my stream, because you take your Christmas tree, your wellhead, which is an assembling of various valves, talking about the swap valve, the manual valve, flow line, choke system, all of that that makes the various production valves of the Christmas tree. So, like I said, this is the Christmas tree, and this is one of the things that I got from the last BHP surveys that was carried out by the subsurface team. When I mean BHP, I'm talking about the bottom hole survey. So I got some parameters from the team in order to see the current life of the well and see, and they must have modeled how long it could take to produce the well. So when I take this information, I make those inputs in my various stream. With this particular gas well, it's the current water cut is about 18% from what I was able to get from this. This is the gas oil ratio, the density of the fluid, and this is the water oil ratio, as the case is. And this is the condition. When I took it to the pipe seam, I talked about the top of the wellhead. This is the THP. So at the top of the wellhead, it's actually 2,100, and this is the current temperature of the well. So the whole essence of the wellhead is to control the flow that is coming to the surface, and there is this very important aspect of that asset, which is the choke. When I mean the choke could come in different sizes. They could also come in different types. It could actually be adjustable. It could be fixed. But for my own process, I've actually modeled this after an adjustable one. For fixed one, you'll have to shut down the well in order for you to change the choke, either to 16, either to 24, either to 36, depending on what you want to achieve. So I have actually modeled this control valve to reflect what a choke system looks like, and in this case it's actually an adjustable one, which is you can actually adjust in real time. When I mean in real time, you want to see what is happening as soon as you change that. Of course, the condition will also take time to cascade all the way from the top to the bottom, as the case may be. Now, when you do this is a running system. Like I said, it's already running dynamic. I want us to take a case of this particular well, this one here. So the current gas production is about 28 million scoff. I have the table here. This is the table here. And I also have the accumulated 35 million scoff of gas that is also going through the NAC system, which comes with the commingled one of this and this that makes up this one. You also have the stabilized liquid that gives you about 1,386 barrels of condensate. So all of that will be going to the flow station, apart from the overhead of the NAC system that will be going through the dehydration process and all of that. And for the low pressure ones, those ones will be going through the compression stages. So, like I said, when you are dealing with the well-edge model, it is very important that you consider the transient assets. I mean, aspect of the flow. When I mean transient, which is you actually want to see how the flow, behavior is with distance. With when I mean with respect to distance. Now, for this particular flow line, which is all the way from the well, this is a coverage of about 1.3 kilometer, and this has been modeled as the manifold, the production manifold, and this is the NAC system that receives the well. So take for example, I'm operating the system at the facility, and I really want to see what happens to my system, because all of this that you have done is based on sizing. You want to ensure that you have sized your various equipment, your various resistant equipment, according to the current, according to the flow. And you must also consider that whatever you are doing that with respect to futuristic capacity of the plant. You are not building a plant for a 10 million scoff in the future, and all you have done is to design the vessel for 1,000, let's say 1 million scoff of gas, when you are trying to achieve 10 million scoff. Of course, by the time you now increase capacity, the vessel won't be able to handle that. So you must do all of that. Currently, this particular model is processing about 43 million scoff, but the truth is that it can go beyond that. If you look at my NAC system now, my NAC system is actually handling there about 35 million scoff, but it can still go beyond that because I have factored that in my calculation. So let's quickly run through how to control that. Let's just test the water as the case is now. If I take this to manual and I want to cut production by half, I could do this. Just go 25% and the gas volume will automatically drop. Now this has dropped to 14 million scoff, and the commingle of both stream 1 and this other stream has also dropped. So when you look at the current condition, you can begin to see the things that have changed with respect to that. You try to assess the entire condition. Now you can still go back to your flow line. It is very necessary. You can't just conclude or be too confident that okay, everything is going to be fine and all that. Of course, you have to design your pipeline, when I mean your flow line, to fit in for when I mean high production as case may be. It just have to be standard. So, but you still have every need to come to this place, check your aeration velocity, see what it is, and then when you look at that and you have actually done what you call a walk through your system, see how your separators and all of that respond, see what your compressors are saying. Like I said, it's an integrated facility. See the rest, see what your reboiler is doing, see what your absorber is doing for gas dehydration. If you look at this, of course this has dropped to 35 million scoff before because I have cut the gas production. You could as well check the ppm. This has dropped to, this is actually 0.002, which is okay. The reboiler is maintaining the right pressure, which is 385 degrees Fahrenheit. You could see how this is responding. All of that, the process is quite stable despite the cut in production. I could as well just increase the daily production. Let's do 50 first. Take it gradually, then do 70. 50 in this case is default, but I have gone up just to see what the condition is going to look like. Now, this was 35 million scoff. It has gone up to 45, probably still going up. Then, look at your vessel. Look at the liquid percent level. You could see that your vessel is doing the right job. and also the control valve is properly sized to handle all of that. These are some of the things I use. You could see API 14 IP for my piping. These are some of the um, data that you reflect on in order for you to do your sizing. When you want to do your hand calculation, these are some of the things I reflect on to be sure that I am doing the right thing. So as the case is, I think I am quite comfortable with what I have here. But going forward, I will be doing something probably when I'm done with uh, the presentation of the entire first section. Then I could start touching on each of the equipment on how I came about their sizing and all of that. Then I can even get other professional inputs. So for now, this is where I'm going to stop. Okay, let me take this back to the default production for the day, so that my boss won't be angry that did I get the instruction of increasing the production. So it's back on auto, then we are good. Thank you.